Now result, two lines in the space, everything we are taking in space. Suppose lines are, vector r is a1 plus lambda times vector b1, lambda belongs to r, and second line is vector r is vector a2 plus lambda times vector b2. Here we change symbol of this parameter, we take mu belongs to r. These are two equations of two distinct lines in the space. These lines are coplanar, that means they lie in the same plane. Lines are coplanar, that means either they are parallel or they are intersecting. Two possibilities. Either lines are parallel, then there exists a plane containing both lines, and if lines are intersecting, then also there exists a plane containing both the lines. So lines are coplanar, that means lines are either parallel lines or intersecting lines. So condition that lines are coplanar is if and only if vector b2 minus vector b1 dot vector a2 minus vector a1 dot b1 cross b2 equal to 0. If a dot product of these two vectors is 0, then both the lines are coplanar. If lines are coplanar, then this is true. So we use here if and only if. If and only if. So this is the condition. It is necessary and sufficient condition. Now we can put its Cartesian form. Cartesian form of this result. Now see, if vector a1, is, suppose x1i plus y1j plus z1k, vector a2 is x2i plus y2j plus z2k. That means point on first line has coordinates x1, y1, z1. Coordinates of a point which lie on second line is x2, y2, z2. Vector b1 is a1i, b1j, c1k. a1, b1, c1 are direction ratios of vector b1. b2 is a2i plus b2j plus c2k. Then its Cartesian form is, then lines are coplanar if and only if now converting this into Cartesian form, keep determinant equal to 0. Vector a2 minus a1, vector a2 minus a1, that is here we keep x2 minus x1, y2 minus y1, z2 minus z1. In second row of matrix keep b1, components of vector b1, scalar components, that is a1 b1 c1, here a1 b1 c1. Then components of vector b2, a2 b2 c2. So if this determinant is equal to 0, then we say lines are coplanar. First line passing from x1 y1 z1, second line particular point is x2 y2 z2, and their directions are defined by vector b1 and vector b2, whose direction ratios are a1 b1 c1, a2 b2 c2. Now to understand this question, let me take one example. To understand this condition, taking example, show that these lines are coplanar. See, equations of lines are in Cartesian form. So let me take these values which we have to put in this condition. See here, x1 y1 z1, it can be seen in first equation. See, x1 is minus 3, y1 is 1, z1 is 5. Then x2 y2 z2, so x2 is minus 1, y2 is 2, z2 is 5. These are a1 b1 c1. a1 is minus 3, b1 is 1, c1 is 5. a2 b2 c2, a2 is minus 1, b2 is 2, c2 is 5. Now I take left hand side of this condition. Now here x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2. If this value is equal to 0, then lines are coplanar. So putting values, x2 minus x1, x2 minus x1, minus 1 minus minus 3, that is 2, y2 minus y1 is 1, z2 minus z1 is 0. Then a1 b1 c1, so minus 3 1 5, a2 b2 c2, minus 1 2 5. Now expanding this, 2 into 5 minus 10, so minus 5, minus 1 into minus 15 plus 5, so minus 10. So this is minus 10 plus 10, it is equal to 0. So we have obtained 0. Because this is equal to 0, so by this condition we can say that given lines are coplanar. Now next topic is angle between two planes. So result is angle between two planes. Suppose planes are vector r dot vector n1 equal to d1 and vector r dot vector n2 equal to d2, where vector n1 and vector n2 are normals to both the planes. So angle between two planes is theta. Then this theta can be found by cos theta equal to modulus of vector n1 dot n2 upon magnitude n1 into magnitude n2. And from this result we can say theta equal to cos inverse modulus n1 dot n2 upon magnitude n1 into magnitude n2. You can see that if dot product n1 dot n2 is 0, then numerator will be 0. So cos inverse 0 is 90 degree. So if n1 dot n2 is 0, then these are perpendicular vectors. So theta will be 90 degree or pi by 2. And if n1 dot n2 term which is in numerator and term it is in denominator. Now see, this can be also negative. So I keep here modulus. So this is a term which is in modulus. So this is numerator, this is denominator. If these numbers are equal, then this ratio will be 1 and cos inverse 1 is 0. So then theta is 0. That is, if theta is 0, then both the planes are parallel. Say this is a vector form. Now to convert this into Cartesian form of this result, angle between two planes a1x plus b1y plus c1z equal to d1 and a2x plus b2y plus c2z equal to d2. These equations are in Cartesian form of planes. So angle between these two planes is theta, then cos theta is modulus of dot product of n1 and n2, that is a1 a2 plus b1 b2 plus c1 c2 upon magnitude of n1. Magnitude of n1 is square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. So this is cos theta, that means theta is cos inverse modulus a1 a2 b1 b2 plus c1 c2 upon square root of a1 square plus b1 square plus c1 square root of a2 square plus b2 square plus c2 square. So this is Cartesian form. And if, now see this statement, if n1 dot n2, this is n1 dot n2, a1 a2 plus b1 b2 plus c1 c2 is 0, then theta is 90 degree. And here, if modulus of a1 a2 plus b1 b2 plus c1 c2, numerator is equal to denominator square root of a1 square plus b1 square plus c1 square into a2 square plus b2 square plus c2 square. If these values are equal, then theta is 0 degree. Now to understand this formula, we take question that find angle between two planes. Suppose equation I am putting 2x minus 3y plus 4z equal to 7 and x plus y minus 3z equal to 9. Using vector method, find equation of find angle between two planes using a vector method. Vector method, that is by this formula. So to use vector method we require vector n1 and vector n2. That means normal of both the planes. So see, from equations here, vector n1 is, so n1, that is, take coefficients of x, y, z. Coefficients of x, y, z are scalar components of vector n1. So that is 2i minus 3j plus 4k. Vector n2 take from these coefficients. Vector n2 is 1i plus 1j minus 3k. Then now formula, if angle between planes is theta, then theta is cos inverse modulus of n1 dot n2 upon magnitude n1 magnitude n2. Now we calculate a dot product in numerator. Dot product of these two vectors. So 2 into 1 is 2 plus minus 3 into 1 is minus 3 plus 4 into minus 3 is minus 12 upon square root of, now magnitude of n1. Magnitude of n1 is 4 plus 9 plus 16 into square root of magnitude of n2. So 1 plus 1 plus 9. That is cos inverse modulus of, say 2 minus 3 is minus 1, minus 1 minus 12 is minus 13 upon square root of 29 into square root of 11. That is cos inverse. Now magnitude modulus of negative is positive. So 13 upon, this is root 29 into root 11. So 290 plus 29. So 319. 290 plus 29, 319, root 319. So this is required angle. Now determine whether the planes, these planes are given. Here, say 7x plus 5y plus 6z plus 30 equal to 0, 3x minus y minus 10z plus 4 equal to 0. These are planes. Determine whether these planes are parallel or perpendicular, and in case they are neither, find angle between them. Say here from these equations, A1 is 7, B1 is 5, C1 is 6. These are direction ratios of normal to the first plane, and A2 3, B2 minus 1, C2 minus 10. These are direction ratios of normal to the second plane. Now we check ratio of these direction ratios. So see here, A1 by A2 is 7 by 3, B1 by B2 is 5 by minus 1, C1 by C2 is 6 by minus 10. If these three ratios are equal, that means normals to both the planes are parallel. If normals are parallel, say whenever in given two planes, say these are two parallel planes, this is normal to the first plane, this is normal to the second plane. Normal n1, a1i, b1j, c1k. This is a2i, b2j, c2k. If planes are parallel, then these normals are parallel. And if two vectors are parallel, then ratio of their direction ratios are in proportion. Means their direction ratios are in proportion. So a1 by a2 equal to b1 by b2 equal to c1 by c2. So in this case, this happens. Two vectors are parallel, then their direction ratios are in proportion. If direction ratios are in proportion, then two vectors are parallel, and normals are parallel, that is planes are parallel, because these are perpendicular vectors. So see, here check this ratios, a1 by a2, b1 by b2, c1 by c2, and we can see that not equal. These are not equal. All three must be equal. If all these ratios are equal, then planes are parallel. So here this condition is not satisfied, therefore these planes are not parallel. So first point is verified. Now second point, are they perpendicular? If planes are perpendicular, say suppose this plane is perpendicular to this plane. If planes are perpendicular, it is possible if normal to the first plane and normal to the second plane are perpendicular. Say here this wall and this flooring are perpendicular. So that's why normal to this wall, it is in this direction, and normal to the flooring, it is in this direction. So say this is n1 and this is n2. So they are perpendicular. So here n1, n2, normals are perpendicular, so the dot product is 0. So now we check, are they perpendicular? So we take dot product of normal. So here a1 into a2 plus b1 into b2, this is dot product. So a1 into a2 is 21 plus b1 into b2 is minus 5 plus c1 into c2 is minus 60. See, this is not equal to 0. So planes are, these planes are not perpendicular. So therefore, if angle between them is theta, then theta is cos inverse modulus a1 into a2 plus b1 into b2 plus c1 into c2 upon square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. So that is cos inverse modulus. Here already we have calculated. It is 21 minus 5 minus 60. 21 minus 5 minus 60 upon square root of a1 square plus b1 square plus c1 square, 49 plus 25 plus 36. Here square root of 9 plus 1 plus 100. So cos inverse 21 minus 5 is minus 16, minus 16 minus 60, so minus 76. 21 minus 5 is minus 16, minus 16 minus 60 is minus 76 upon square root of 1110 into 1110. So this is cos inverse 76 upon 1110. So this is angle between these planes. Now distance of a point from the plane. If plane is, this plane is ax plus by plus cz plus d equal to 0 and point is x1 y1 z1, we want this perpendicular distance. So distance of a point x1 y1 z1, this distance d, already we have used here d, so we don't use d. Distance of a point x1 y1 z1 from this plane ax plus by plus cz plus d equal to 0 is modulus of, say, whenever you use formula here in equation of plane, here there must be 0. 0 is must. Then in this part here replace x by x1, y by y1 and z by z1. x, y, z replace by x1, y1, z1 plus d upon square root of a1 square plus b1 square plus c1 square. So that is formula. Now we can also put its vector form. So its vector form is suppose plane is vector r dot vector n is d, and here this is a point whose position vector is vector a. Here we want this distance. Suppose position vector of this point here, suppose that this is vector a, or we use a different symbol. Suppose this is vector p, position vector of p is vector p. That means this will be origin. So we say perpendicular distance, perpendicular distance of point P whose position vector, having the position vector vector P. You can also use symbol vector A. So perpendicular distance of a point having position vector vector P from plane r vector r dot n equal to d is, see, modulus of, you can learn or you can memorize from this form. Now see, observe this part. So what is it? It is a dot product of vector n and vector p. So we should keep here a dot product of vector n and vector p. Then this is 0. So constant is taken on this side. So if you take this number on this side, so it is minus d upon, this is a magnitude of vector n. Now to understand the result, taking a question to find distance of a point from a plane. As for example, find distance of point 2 minus 1 5 from a plane 2x minus 3y plus z equal to 7. So see, to apply this formula, RHS should be 0. So here 2x minus 3y plus z minus 7 is 0. So first of all, if RHS is non-zero, set 0. Now required distance is formula is modulus. See, what is the method? In this left hand side, replace x, y, z by x1, y1, z1. So 2 into 2 minus 3 into minus 1 plus 5 minus 7. So x, y, z replaced by x1, y1, z1 upon magnitude of vector n, that is root a square plus b square plus c square. So square root of 2 square is 4, minus 3 square is 9, 1 square is 1. So that is modulus of 4 plus 3 plus 5 minus 7 upon square root of 14. This is 7 minus 7 is cancelled, 5 upon root 14. So required distance is 5 upon root 14. Now next topic is angle between a line and a plane. When a plane is given and a line is given, this is a line. Angle between a plane and a line, that means it is an acute angle which is formed at intersection point. So this angle, to find this angle, we will use normal to this plane. Say normal is, this vector is normal and this is vector B. It is a direction showing vector, direction of line. So using these two vectors we can find angle between line and a plane. So angle between line, suppose equation of line is vector r is equal to vector a plus lambda times vector b. Lambda belongs to r and plane is vector r dot n equal to d. If angle between them is theta, then this theta can be found by cos theta equal to modulus of vector, here we use sine theta equal to modulus of vector b dot vector n upon magnitude of b, magnitude of n. That is theta is sine inverse modulus of vector b dot vector n upon magnitude of vector B, magnitude of vector n. So here we use direction of line and normal to the plane, and here we use sine theta. So now question on this formula. Say suppose question is find angle between equation of line. I am putting x minus y 1 by 2 y plus 3 by 4 equal to z by 5, and equation of plane is suppose 2x minus y minus z plus 8 equal to 0. We want angle between line and plane. So see, from this equation, vector B, here vector B is, that is scalar components are visible in denominator. So 2i plus 4j plus 5k. Always keep remember, before taking vector B, every time you should check these variables. Here coefficients of x, y, z must be 1, 1, 1 in each. If it is 1, 1, 1, then these numbers are direction ratios of vector B. And vector n is, that is coefficients of x, y, z. So 2i minus 1j minus 1k. Now formula, theta is sine inverse vector B dot vector n upon magnitude of B, magnitude of n. So sine inverse is modulus of dot product of these two vectors. 2 into 2 is 4 minus 4 minus 5 upon magnitude of vector B is 4 plus 16 plus 25 and into magnitude of vector n is 4 plus 1 plus 1. So this 4 is cancelled. So sine inverse modulus of minus 5 upon, it is root 45 into root 6, that is, this is sine inverse 5 upon, now root 45 is 3 root 5, so 3 into root 5 into root 6 is root 30. So this is angle between line and plane.